Hello everyone, myself Vikas S. Kumar and I'm studying in Sri Venkateshwara College of Engineering, ISC 3rd Sem. In this video, we are going to learn about additional list operations, sparse matrices, double linked list. Linked list operation, traverse, insert and delete. There are various linked operations that allow us to perform different actions on linked list. For example, the insertion operation adds a new element to the linked list. Here, a list of here is a list of basic linked list operations that we will cover in this article. Traversal. Access each element of a linked list. Insertion adds a new element to the linked list. Deletion removes the existing element. Traverse a list. Traverse a linked list. Displaying the contents of a linked list is very simple. We keep moving the temp node to next one and display its contents. When temp is equal to null, we know that we have reached the end of a linked list, so we get out of a while loop. Insert element to a linked list. You can add elements to either the beginning, middle, or the end of a linked list. Insert at the beginning. Allocate memory for a new node. Store data. Change next new node to point to head. Change the head to point to the recently created node. Insert elements at the middle. Allocate memory and store data for new node. Transfers the node just before the required position of a new node. Change the next pointers to include new node in between. Insert at the end. Allocate memory for new node. Store data. Transfers to last node. Change the next of a last node to recently created node. Delete from the linked list. Delete from middle. Transfers to the element before the element to be deleted. Change the next pointer to exclude the node from the change. Transfer to the second last element. Change its pointer to null. Point the head to the second node. Introduction to sparse matrices. Sparse matrices are matrices that contain a large number of zero elements. In contrast to dense matrices, sparse matrices have significant number of empty or insignificant entries. Sparse matrices are commonly encountered in scientific computing, network analysis, and data comprehension. Representation of sparse matrices. Sparse matrices can be represented using different techniques such as coordinate list, COO, compressed sparse row, CSR, compressed sparse column, CSC. COO representation stores the non-zero elements along with their row and column indices. CSR and CSC representations store the non-zero element in compressed format, reducing memory usage. Operations on sparse matrices. Operations on sparse matrices include addition, multiplication, transpose. These operations require specialized algorithm to efficiently handle the sparse structure. Sparse matrices operations are widely used in areas like graph theory, numerical analysis, and image processing. Double linked list. Doubly linked lists are a type of data structure used in computer programming. Thus, they are similar to regular linked lists but have added feature. Each node in doubly linked list contains pointers to both next and previous nodes. This bidirectional linking allows for more flexibility in traversing the list. With the regular linked list, you can only traverse forward from one node to next. However, with dual linked list, you can traverse both forward backward as each node holds reference to its previous node. This additional linking capability makes operations like inserting deleting nodes at any position in the list more efficient. In a doubly linked list, you can easily update the pointers to adjacent nodes when performing such operations. Doubly linked lists are commonly used in scenarios where you need to traverse a list in both directions or perform frequent insertion and deletion within the list. However, they do require more memory compared to regular linked lists due to the extra pointers. Structure of double linked list. Imagine you have a chain of nodes where each node has two parts, data and pointers. The data part stores the actual value or information you want to store in the list. The pointer part consists of two pointers, one pointing to the previous node and another pointing to the next node in the list. To visualize it, think of nodes as boxes connected by arrows. Each box holds some data, and the arrows indicate the connections between the nodes. In Ghibli linked list, each box has two arrows, one pointing to the previous box and one pointing to the next box. This structure allows you to move forward and backward through the list easily. You can start from any node and follow the arrows to reach the next or previous node. This bidirectional movement is what makes double linked list special compared to regular linked list. With double linked list, you can perform operations like inserting a new node or deleting an existing node more efficiently. When you insert a new node, you update a pointer to the adjacent node to maintain the connections. Similarly, when you delete a node, you adjust the pointer of neighboring nodes to keep the list intact. Overall, the structure of double linked list consists of nodes connected in a chain where each node has two pointers, one pointing to the previous node and one pointing to the next node. Traversal of double linked list. Traversal refers to the process of visiting each node in linked list in a specific order. In case of double linked list, you can traverse it in two directions, forward and backward. To traverse the double linked list forward, you typically start from the head node, the front node, and follow the next pointer until you reach the end of the list. You can perform operations or access data at each node as you move forward. To traverse the double linked list backward, you start from the tail node, the last node, and follow the previous pointer until you reach the beginning of the list. Again, you can perform operations or access data at each node during the traversal. In the both forward and backward traversal, you can use a loop or a recursive function to iterate through the list. The loop or a recursion continues until you reach the end or the beginning of the list, respectively. Traversing a double linked list allows you to access or modify the data in each node, performs calculations or specific search a specific element. It provides flexibility in navigating through the list in both directions. Insertion in double linked list. Insertion in double linked list involves adding a new node at a specific position within the list. The process typically includes three steps. First, creating a new node. First, you create a new node that contains the data you want to insert. Second, adjust the pointers. Next, you update the pointers of a neighboring nodes to accommodate the new node. This involves modifying the next pointer of a previous node to point the new node and the previous pointer to the next node to point to the next to the new node as well. Additionally, you update the next pointer of a new node to point to the next node in the list and previous pointer of a new node to point to the previous node in the list. Third, updating the head and tail. If insertion happens at the beginning or end of a list, you need to update head or tail pointers accordingly. By following these three steps, you can insert a new node at any position in double linked list, whether it's at the beginning, end, or somewhere in the between. The process remains same. The bidirectional nature of double linked list makes insertion more efficient compared to singly linked list. Advantages of double linked list. Double linked lists have several advantages over the types of linked list. Here are some advantages using double linked list. First, bidirectional transversal. Unlike single linked list, double linked list allows you to traverse the list in both forward and backward direction. This makes it easier to navigate through the list, perform operations in either direction, easy to insert and delete. Easy insertion and deletion. Adding or removing a node in double linked list is more efficient compared to singly linked list. With the help of previous and next pointers, you can easily adjust the neighboring nodes when inserting or deleting a node without the need of traversing the entire list. Efficient removal of nodes. In double linked list, removing a node is more efficient than in single linked list since each node has previous and previous and next pointer, you can directly access the neighboring nodes and update their pointers without the need to traverse the list to find the previous node. Flexibility in implementation. Double linked list provides flexibility in implementing various data structures and algorithms. They can be used to build other data structures like stacks, queues, and circular lists. Fifth, reverse traversal. Due to the presence of previous pointers, double linked lists allow for easy reverse traversal. This can be useful in scenarios where you need to process the list in reverse order. These are some advantages of double linked list. They offer increased flexibility and efficiency compared to singly linked list, especially when it comes to traversal, insertion, and deletion operations. Conclusion. In conclusion, double linked list provides several advantages over the other types of linked list. They allow bidirectional traversal, making it easier to navigate through the list in both forward and backward direction. Insertion and deletion operations are more efficient in double linked list due to the presence of previous and next pointers, which allow for easy adjustment of neighboring nodes. Removing the nodes is also efficient compared to the singly linked list. Double linked list offers flexibility in implementing various data structures and algorithms and allow for reverse traversal when needed. However, it's important to consider the trade-offs. Double linked list requires more memory compared to single linked list due to the additional previous pointers. Additionally, maintaining the integrity of double linked list can be more complex as you need to ensure the previous and next pointers of a neighboring nodes are properly updated. Overall, double linked lists are powerful data structures that can be beneficial in certain scenarios where bidirectional traversal, efficient insertion and deletion, and reverse traversal are important. It is essential to be careful, evaluate the requirements of a specific use case before deciding use a double linked list. Thank you.